Hi everyone, welcome back. Today we are diving into a powerful combination, the strategy design pattern with generics. If you are looking to make your code more flexible and maintainable, this video is exactly what you need. By the end of this video, you will understand how to implement strategies that work seamlessly with different data types, making your code both elegant and extensible. Let's get started. The strategy pattern is a behavioral design pattern that enables selecting an algorithm at runtime. Instead of implementing a single algorithm directly, code receives runtime instruction specifying which algorithm to use. Think of it like this. Imagine you need to travel from point A to B. You could walk, drive, or take public transport. Each is a different strategy for the same problem. The strategy pattern allows you to swap these approaches without changing your core application. Let's look at a basic strategy implementation. First, you need to create a strategy blueprint by designing an interface. For this case, we have a payment strategy. Then you need to define concrete classes which implement defined strategy interface. First, credit card payment strategy, which takes a card number. Second, PayPal payment strategy, which takes an email. Now let's define a context class with checkout method. This works well, but what if we want our strategies to handle different types of data? This is where generics come in. Generics in Java allows us to write a code that works with different data types. They use type parameters to specify the types that a class or method can work with. The basic syntax looks like this. I have a box class of type T. Here T can be anything like integer, string, double, or any complex object. Now once I have defined a generic class box of type T, I can use it for any data type. The power of generics is that they prevent type errors at compile time rather than runtime, and we know it is always better to throw a compile time issue rather than runtime nightmare. Now let's combine the strategy pattern with generics to create something truly flexible. Here's where things get interesting. By using generics with the strategy pattern, we can create strategies that process different types of data while ensuring type safety. Let's implement a validation system that works with different data types. First, let's define a strategy interface with validate method, which can take any data of type T. Let's define some concrete classes. Email validator, which can validate if a string is valid email or not, and age validator, which can validate if age is within some range. Now let's define context class, user profile of generic type T. In constructor, we will define what strategies to use at runtime. Then set data will first validate and assign the value, and get data can be used to retrieve the data. Now let's see this in action. First, let's see how email validator works. Then same user profile generic class I will be using for age validation. Did you notice how our user profile class works with different data types? And each has its own validation strategy. This is the power of combining these two concepts. Let's look at another practical example. A generic sorting system that can work with any comparable data. Again, first define a strategy interface. Create two concrete implementation, quick sort and merge sort. For the simplicity, I'm just calling collection.sort under the hood. Then define a context class data sorter. Now we can use this flexible system with different data types. First, let's sort list of strings using quick sort. Then sort list of numbers using same context class with merge sort. This example shows how we can apply different sorting strategies to different data types while maintaining type safety. The combination of a strategy pattern with generics offers several benefits. Type safety, compile time type checking prevents errors. Code reusability, generic strategies can be used with multiple data types. Flexibility, we can swap algorithms at runtime. Maintainability, new strategies can be added without modifying existing code. Common use cases include validation systems, different payment processing methods, multiple sorting or filtering algorithms, data conversion strategies, authentication mechanism. And one more example I would like to give of cache. In cache we have different eviction strategies like TTL, LRU, LFU. You can apply strategy design pattern there as well. And if you include generics in there, you can implement cache of any data type T. That wraps up our look at implementing the strategy pattern with Java generics. By combining these two powerful concepts, you can create flexible, type-safe, and maintainable code. If you found this helpful, please like and subscribe for more Java design pattern tutorials. Drop your questions in the comment below. Happy coding!